Yay!
Yay! All right, someone wants to give you $1 million. Sounds great. And then they say, do you want it in gold or do you want it in $100 bills? I don't know. Maybe one. Maybe could you carry $1 million in gold? Would $1 million in $100 bills, would it fit in your car? I don't know. It's not obvious when you think about it. So let's use some of the techniques were used for units, and let's talk about the density of things and how valuable things are. And maybe we can find out something interesting about $1 million. Would you rather have it in gold or would you rather have it in $100 bills? All right, let's see. A couple of things that I can write down. I looked up a couple of parameters for gold. Okay, gold is chemical symbol AU, and it has a density. Over and over again in physics, we'll use the Greek letter rho for density. It has a density of about 20 grams per cubic centimeter. It's like 19.3 or whatever. This is one of those exercises where I'm going to feel free to estimate things, because I don't care how exact the weight of the gold is. We just want to, roughly how big is the gold, or how big is the container of $100 bills. So we can estimate a little bit. So gold is 20 grams per centimeter cubed. And then I also looked up today's price of gold, and it's about $2,000 per ounce. That's particularly not very helpful, because in physics we don't really use ounces. We use grams and so on. So I have to convert. And even worse, when they give the price of gold, it's usually in what's called a troy ounce, which is it's not even like regular ounce. So anyway, we have to convert, and it turns out that it is, if I divide by 30 grams per ounce, then that gives me kind of an interesting number, which is a little bit more useful for us, which is if I divide the 2,000 by the 30, looks like that's going to give me dollars per gram, right? The ounces are going to cancel. So it turns out that gold is going to be about $67 per gram. Neat. Well, look, I've got grams here and I've got grams here. If I multiply those two things together, the grams are going to cancel. And so that's going to give me a number, which is kind of interesting, which means that gold is going to be about, I've already done the calculation ahead of time, $1,330 per cubic centimeter. Neat. So a little, we used to say sugar cube. I don't know if people know what a sugar cube is, but just a little square cubic centimeter of gold is going to cost you about $1,330. Well, that's its market price anyway. $1,330 cubic centimeter. Neat. All right. So what we're going to do with that is, how big would $1 million of gold be? Well, I know it's $1,330 per cubic centimeter. What if I did this? So what's $1 million? $1 million is 10 to the $6. So 10 to the $6 divided by $1,330 per cubic centimeter gives me about 750 cubic centimeters. That's how big $1 million of gold is. So if that's a box, I mean, if you just take the cube root of that number, that'll tell you how big of a cube, how big on each side the cube would have to be. And it's going to be something like 9 centimeters on a side, right? I just made it worse. So a cube about 9 centimeters on a side, a little bit bigger. That's going to be $1 million worth of gold. And how much is it going to weigh? Could you even lift it? Maybe. I mean, 9 centimeters isn't that big. That's, let's see if I can. It's like the size of your palm, maybe a little bit bigger than the size of your palm. Something like that would be 9 centimeters, except it'd be a block. How much would it weigh? Well, I know the density of the gold, right? So the weight, the mass, let's be more specific. The mass of the gold is going to be 20 grams per cubic centimeter times 750 cubic centimeters. So those are going to go away. And what we get is, looks like that's going to be about 15,000, right? So this is about 15 kilograms. And then if you convert that to pounds, it turns out this is another one. Remember, I think the previous video we said that meters per second to miles an hour, you double it and you add 10%. That's actually a useful thing to keep in mind because kilograms to pounds is incidentally kind of the same thing. 15 kilograms, you double it, that makes 30, and then you add 10%, 33. So about 33 pounds would be this block. So could you lift $1 million of gold? Yeah, probably. It'd be a little hard to handle because it's sort of a small cube that weighs 30 pounds. So it'd be kind of, don't drop it. That'll break a foot. But you could lift it. 15 kilograms of gold is about $1 million. Okay, so what about the question, would you rather have it that way or in bills? Okay, so I had to take some measurement. I happen not to have very many $100 bills left, but $20 bills, I actually have those, and it's about the same size. So a bill is about 15.6 centimeters by 6.6 centimeters. So it's about, what's cool about that is that it turns out it's about 100 square centimeters in area, right? What I want is volume, right? How much volume does $1 million take up in $100 bills? Well, it's tough to measure the volume of one bill, but what if I stack? Here's something else that I didn't do because I don't have a stack of bills. But I think that if I stacked 100 bills together, it would be about a centimeter thick. I think that's about right. So that's pretty neat. So 100 bills, 100 $10 bills, that's $10,000, right? So that's 10 to the $4 is 100 cubic centimeters because it's 100 square centimeters times 1 centimeter thick, right? So this would be something that looks like this. Here's my stack. This is like 15.6 and this is like 6.6, something like that. Okay, neat. So my bills is something like $100, dividing those two. The density, the money density of bills, $100 bills, is about $100 per cubic centimeter. Kind of a cool way to think about that is that apparently one bill, if you mashed up $1 bill as small as you could, it would take up 1 cubic centimeter, right? That's the volume, one bill. Okay, so that's sort of the money density of bills. Compare that with gold. What was gold? It looked like gold was $1,330 per cubic centimeter, and the money density of bills is 100, right? So gold is definitely more dollar dense than bills. The advantage to the bills is that they weigh less, right? So I also looked up that each bill weighs 1 gram. That's kind of cool. So $1 million, 10 to the $6 divided by, first of all, let's do the volume. $100 per cubic centimeter, right? That's going to give me 10 to the fourth cubic centimeters. So how much room does $1 million worth of $100 bills take up? Well, it looks like it's about 10,000 cubic centimeters. 10,000 cubic centimeters. What kind of a box is that? That's a box that is about 21, it turns out. A little over 21 centimeters on a side. It's a shoebox. Maybe for fairly large shoes. But anyway, roughly something the size of a shoebox. So you could stuff a shoebox full of $100 bills and you'd have $1 million. And then how much does it weigh? Well, there's 10 to the fourth. Well, let's see. There's 10,000 bills, right? Because 10,000 times 100 on each bill gives you $1 million. They each weigh a gram. So that must be 10 kilograms. So there's sort of an interesting result that definitely, you might have imagined this anyway, $1 million in $100 bills would take up more room, but maybe not that much more. It's a shoebox compared to something that is maybe, I have this sort of Rubik's Cube sized. This is a little smaller than the gold, but this would be something like maybe $300,000 worth of gold, something like that. So $1 million in gold would be something like a little bit bigger than the Rubik's Cube, but for $100 bills, it would be like a shoebox, but it would weigh less, right? Instead of 15 kilograms, it'd be 10 kilograms. So it's sort of up to you. How would you want to take the $1 million? You could take it either as a shoebox full of bills, or you could take one, 33-pound nugget of gold. It's up to you. But it's kind of an interesting exercise to work through this stuff.